We are live.
All right. So, depending where you're from, good evening, good morning. Welcome here at this LFDT. Actually, it's a LFDT Belgium meetup originally, but because we're hosting it online, um, yeah, it's a worldwide meetup. So, welcome here. I'm personally very excited about this topic, trusted AI agents. I think I don't need to explain to anyone how popular and how rapidly advancing the domain of AI is. As the capabilities of AI grow, the potential for AI agents acting on our behalf in a non-deterministic way is also growing very fast. But how do we trust them? How do we give them access to the data they are allowed to get access to? And how do we know which agent did what? And many other questions. In that regard, trust is needed. And as things are growing very fast and big players are starting to emerge, this seemed like a very timely topic to organize a meetup on. And we're very lucky to have two very big experts on this topic. One is Andor Kesselman, among others, founder of the IF Labs, but I think he will much better explain all the projects he's involved in. And Geoff Pirie, who sadly couldn't be live with us today. However, he provided the recording, and he's the director of product at Enrupt. And Enrupt is also well known for Solid. So I would just continue. So some key questions that might be interesting to get answers on during this meetup is how can agents be reliably identified and trusted across diverse environments? What delegation models ensure agents act appropriately on behalf of users? How can granular permissions enforce least privilege data access? And where should agent-generated data be securely stored for interoperability and persistence? These are just some questions I came up with. I'm sure there will be many more questions arising in your minds from your frame of reference, so don't hesitate to write them in the chat. At the end of the meetup, there will be enough time to handle a lot of questions. So the agenda first will be the recording of Enrupt on their concept of agentic wallet. Then we'll have Andor Kesselman on scaling the agentic web, new challenges and areas of innovation. Then we'll have 20 minutes for a moderated Q&A, and that will be it. Just a short word why I am here and why we are doing this or organizing this. We at HOS Cyber 3 Lab provide education and applied research in AI, cybersecurity, immersive technologies, and digital trust. We are part of the HOS University of Applied Sciences, located in Bruges and in Kortrijk in Belgium. We are very involved within LFDT. We are a co-founder of the European chapter. We took the credentials here. We speak at OSS events and we organize these kinds of meetups. If there's a topic you would like a meetup to be organized on, you can always contact us to collaborate. And last thing about us before I move back to the topic is we also provide some masterclasses, among which is also one on identity and Web3. So feel free to check them out and to ask more questions if you have them. And then now I will first move to the recording of Geoff. So 1 second.
Hi, good evening. My name is Geoff Pirie. I'm the Director of Product here at Inrupt, and I want to talk to you this evening about our Agentic wallet. And I also want to thank Shane for inviting me to the session, but also to apologise for not being able to be there, sort of be here in person, and also participate in the panel. Unfortunately, due to a clash of travel arrangements, I won't be able to attend at the time it's live. So forgive me for the recording, and hopefully we can get through this without too many mistakes on my part. So to begin with, I want to just talk a little bit about Inrupt and our view of why agentic wallets matter before talking a bit about how we've going about implementing those and some of the technology we're using. And hopefully at the end, I'll be able to give a brief demo of our wallet and agent in action. So to begin with, I just want to talk a bit about sort of how we got here. So obviously the web, we all know the web, and 1.0 of the web was really what we call the read-only web. And so you could publish a lot of data, but interaction was really driven by reading the content that was out there and not much in the way of interactive or dynamic behavior. As the web evolved, then so did a host of technologies, and the Web 2.0 really became the read-write web, where large platforms and technology services evolved to the extent that we could then interact with the web. And the web that we all experience today is really the sort of the pinnacle of Web 2.0 thinking, and the platform experiences that we get there today, things like Facebook and Google and so on, dominate a lot of the global population's experience of the web. As a consequence, though, then really these sort of colossal technology companies have sort of dominated and do dominate our experience. And so these large digital colonies have formed where platforms really intentionally try to capture and extract value from individuals like myself and you by capitalizing on the data that we're able to bring to those platforms. And there is this sense of choice that you can sort of opt in and opt out of things, but really practically that choice is an illusion because we have to kind of consent to them using data, the terms and conditions, terms of service, demand it, if we want to experience those platforms. So the Facebook experience is only available if you kind of comply with the terms and conditions. So whilst you can opt out, you also miss out. And so you don't really get that much choice. And as a consequence, the data about us that they are gathering is working for them more than it does for us. And we lose agency over our experiences and ourselves because we've lost control of our data. So really what we're doing is trading convenience, the convenience we receive for them gaining access to the data. And so really from Sir Tim Berners-Lee's perspective, the guy who invented the web and co-founder of Inrupt, his view is that really browsers and apps have defined Web 1 and Web 2, but things need to change, and that wallets, or digital wallets, data wallets, or some agentic version of those is going to shape Web 3.0. And so why is it we think that wallets are really doing this kind of transformation? Really, this comes about because wallets have become very dominant globally. So there is now this expectation that more than half the world's population, 60% by the end of 2026 perhaps, will be using digital wallets on a daily basis. I know I use mine regularly for payments and so on. And that payment experience is in large part responsible for this increase in growth around wallets. So the Apple ecosystem, the Google ecosystem, Samsung mobile devices all come with variations of a wallet. And of course, in Europe in particular, there is now the evolution of the European digital identity wallet that is, another perspective on wallets. So over time, as adoption has increased, then consumers have become, first of all, familiar with what a wallet can offer, but also want to see what they can do beyond transactions. We're already moving in a little bit beyond sort of payment transactions into the realm of, digital boarding passes, hotel keys, and so on, conferences, and like show and event passes being something that we can now carry around in our mobile device, in the mobile wallet. But again, that's the beginning. How might that experience be transformed if we can change move away from just simple transactional kind of interactions to much more complex ones around more comprehensive sets of personal data? So the current wallet experiences that are dominating at the moment are really this sort of transactional, manual interaction driven by us physically being present, perhaps to tap to pay kind of experience, or boarding a plane and so on, and are driven in large part by the dominant platform vendors like Apple and Google, who provide a wallet that we all typically carry in our pocket. And those exchanges are limited then to the services and capabilities that are on offer through those platforms. From Inrupt's perspective, our view is that the world of wallets needs to change and will be driven in large part by a combination of AI and AI automation and services, and the availability of more comprehensive personal data that is coupled and combined with our consent for its use. And that this is best achieved by delivering those capabilities through a set of open standards. So Solid at the W3C being our chosen standard and the standard that Tim advocates. And as a consequence of this sort of comprehensive sets of data combined with AI and our consent, driven by standards, will allow for organizations, businesses, and individuals to build different kinds of relationships through the data, their personal data, and their management of it through a wallet or some wallet-like experience. Now, all of this is also in the context of a changing landscape. So a lot of regulation is shifting as well around both AI and personal data. And so we're seeing an awful lot of regulation protecting personal data and managing the, obviously GDPR, but then how do agents interact with that personal data over time? There is obviously in Europe the role of the AI Act, providing a framework of governance around how data is used by AI services and protecting consumer rights in that case. Obviously, there's also this sort of continued growth of data usage and a fragmentation of data. So from an individual perspective, the more services I interact with, the more copies of me there are in each of those discrete services that tends not to be connected to one another. And on top of all of this, we've sort of touched on the roles of Apple and Google and the like, who are huge and have these massive sort of captive ecosystems where they're centralizing our data. And if they become sort of the indispensable service, then we are sort of beholden to them and the centralization of our data in those large organizations. So our perspective is that new value is unlocked when we rethink our relationship with data and the way that we go about managing it. And wallets are a mechanism through which we can empower individuals to have more control over their data. So what do we mean when we think about personal data? There's really primarily sort of three big categories of data. So there's today already a huge amount of transactional data about us that can be stored in a wallet, is stored in a wallet. There's also a host of private data, so maybe medical records, gym memberships, personal fitness tracking, all those kinds of things is private data about me that I could have stored in my wallet and put to use through my consented approval of services using that data. And then, of course, there's the sort of the global wealth of public data, which includes data about me. So, for instance, articles I've written are in the public domain, but so are things like terms and conditions, terms of service, organizational privacy policies, and a host of other things that businesses generate that describe and explain the kinds of things that I'm permitted to do with their services and the experiences I can expect. So, from an Inrupt perspective, this is the broad data landscape. And what gets really interesting is where these different types of data intersect. And in the center there, that sort of little purple segment, is where we see the coming together of transactional data, private data, public data, that personal experience, which when you layer on AI can be quite transformative. And so when we bring all this data together and add AI, we can then begin to think about, well, if that's captured by my agentic wallet and I apply AI to it, what can I do? Well, I can begin to transform how I interact with my data. And so today we're already in a world where I can share my personal data, private data with various online services like ChatGPT and Claude from Anthropic and so on. And it will answer questions about it. It can respond to my queries about myself and the data I've supplied it. In due course, as we see the evolution of reasoning models and models that can take action on our behalf, then obviously we'll expect wallets to be able to take that action. So maybe book a hotel in response to my queries and questions about where I could stay. The AI will be able to take action and book on my behalf. And then finally, we expect the world to evolve to a point where obviously these models become very complicated, complex reasoning models and are being able to anticipate the things that we need. But because they have access to our personal data, they'll be able to anticipate the things that really matter to us and personalize our experiences. Now, for all of this to be valuable and to work with privacy in mind, then we need the technology underpinning it to protect and manage our data. And that's where Interup's perspective on Solid comes into play, where we provide the underlying infrastructure that can power these kinds of services, manage the consent and access to that data so that AI is interacting ethically with our data and not effectively breaching our trust. From a business perspective, having data in an agentic wallet like ours also transforms sort of the business perspective on value. And so over time, as more data becomes available to businesses and it's combined with individuals' consent, so I can tap the approve button on my phone, then we can expect new kinds of experiences that drive up increased lifetime value for a business. And because I am getting a more direct feedback from these businesses, more personalized services, and I can see that the data I'm sharing is directly affecting the service I receive, I have an increased desire to make sure that that is good data. So that the data itself about me is something that I am curating and playing an active role in, controlling, because I have visibility of it and also the ability to approve its use, but also revoke that use. So there is this sense that data becomes richer and more accurate if you involve the end user, ourselves, by giving them some amount of control over it. And then finally, from a legislative and regulatory perspective, because data is now in this platform with these controls around it, we create a platform that is safer for AI to act on our data, safer for individuals to understand how their data is being used, because there is this sort of implicit consent associated with all data usage, and because we can identify the agents that are interacting with that data and individually permit them to have access to the data about us. Okay, so this is like the really high level perspective on all of this. I want to kind of go down just a little bit and talk about what we're actually building and how things are changing. So to begin with, I just sort of go right back and recap the world of today is really this sort of sense of legacy data architecture where we have these sort of siloed experiences behavior. I log into something, I interact through an app with the data that that app has about me, but it's not connected to any of the other apps typically that I interact with. So I get this siloed experience of the three different kinds of Geoff that these three different apps understand. So in our world, in the world of digital wallets and agentic wallets, at the base of this diagram, you can see there is this wallet infrastructure, and this is where my data lives. And on the right-hand side, the user can interact and govern the data that's in that wallet infrastructure through the wallet app. So my mobile device is connected to the underlying infrastructure, and I have a means through which I can directly control and manage access to that data. And the apps, those same three apps, I still use those apps, but they're now sat on top of my personal data that I am able to govern independent of them through my wallet. So I still have an identity, I still log into an application, but it now has access through to the data that is effectively stored in my wallet. And my wallet allows me to govern how those applications and services, including AI services, can interact with it. What we've actually built is quite comprehensive infrastructure product. So you can see in the diagram on the right here, this sort of schematic diagram, that fundamentally this is technology that will run in cloud infrastructure and deliver a host of services that combined allow you to deploy wallets for large customer bases at scale. On the left-hand side in the middle there, you can see that we have sort of an identity provider flow through to authentication services. So you can connect our technology to any existing OIDC provider and effectively attach storage and a wallet to an existing login. So existing business applications can just be extended to now have access to and incorporate wallet kind of services. Or you could develop an entirely new wallet application and use some of the UI components and developer tools that we provide to get started with wallet building. And then underneath the sort of the API for application interactions, there are a host of services associated with managing authorization and identity, and how do we identify different services and govern their access to the data, and the data lifecycle management services for how data is created, read, written, updated, and so on. And then sat in the middle there, which is where we start to get into the realm of MCP, is this sense of how do we plug in different large language models and AI services to interact with the data that is stored in the wallet. And underpinning all of this then is the platform security and governance capabilities that ensure both that services interacting with data are doing it with appropriate permission, but also recording everything that all of those interactions into audit trails and providing the robust governance that large organizations need in order to deploy this technology at scale. So collectively, this is what we package up and sell as our product. If we go one level deeper and start thinking about sort of a simple flow between a user and the application's front end and back end, you can see in the center here, there is still this sort of sense of my data in my wallet, and surrounding that, the little sort of dotted boundary represents access control, and everything passes through access control, whether that's a typical application like a UI application, the wallet itself, or back-end services on the right here, where maybe we're storing all kinds of different data, whether it's credentials, user data, the inferences from AI services. All of this has to pass through access control. And so the technology that we talk about in terms of how do you govern access is that services, like AI services, make an access request to gain access to data in my wallet. And then as a user, I use the wallet application to approve that access, which in turn generates an access grant. An access grant is effectively a key bound to the identity that made the request in the first place. So if we look to the bottom right here, you can think about the role of LLMs and introducing commercial LLM services like ChatGPT and so on that are able to interact with data stores through the MCP protocol. And so what's important for us is that these services don't gain some kind of privileged access just because they're AI and they're somehow different, but that they respect the same access control that every other service and every other application has to respect when interacting with this data. And so a big part of the work that we're doing at the moment and actively in development on is the role of building that MCP server and the management of both identity and being able to multiplex identity where you've got multiple back-end services interacting through this sort of single MCP server interface that ESS provides, our product provides, so that you can understand which of those backend services is actually entitled to interact with the data, and then serving up that data in a form that satisfies the MCP contract. And so we're building that MCP infrastructure at the moment, and as a consequence, hopefully we'll be able to come back shortly and be able to give more details on what we've been able to produce and its availability. But it's interesting also, this diagram really presents this in the form of MCP as a back-end service infrastructure, but there's obviously a consumer side to this as well. And so we're looking carefully at that as side of things, where wallets themselves have an AI embedded within them, and that instead of users being, clicking lots of buttons and as the amount of consent that we're asked to give goes up as more services and more policing of our data occurs, then instead of that becoming something that we have to manually interact with every time, we can imagine that perhaps there are some criteria we can set that allows an agent to evaluate an access request and approve an access grant based on those criteria that we've set. And so the agent on the consumer side can begin to effectively govern access to our data on our behalf, albeit with restrictions and control in place. And so that's the other side of things that we're looking at, is how do we simplify user experience in managing data, because otherwise we'll create a world where we're forever barraged with, we already get a lot of consent banners when we visit websites. You can imagine that at scale, when all services are interacting with our data that is stored and governed through our mobile devices, that we don't want to be continually responding to those kind of requests. And so there is a big side of this around the consumer side agent and how that can simplify things for us. And then a couple more slides before we switch over to the demo. So from an Interop perspective, we're building this technology and these integration points so that we can support all of the different LLMs and AI and ML models that are out there. So this slide is really trying to just represent the fact that we recognize there's a host of commercial platforms that large organizations are using, and being able to connect to all of these ultimately is our goal, but the initial effort that we are putting in is around those that support MCP. And then another area that we're exploring that really matters to large enterprise, where they're focused on real privacy concerns, so particularly in the worlds of healthcare, where maybe genomic data and things are present, then there is this sense of how do we manage LLM interactions with that data in a way that means those LLMs are not able to extract that data for training or for any purpose other than those that we deem suitable. And so there is also some work that we're doing at the moment around trusted execution environments, and how do you connect the world of wallets and the data that's stored about them to LLMs in a way that preserves privacy and does not allow the data to escape into the hands of large LLM vendors, but also still allows for the utility to be made available, so that those LLMs can process our data, give us useful inferences, useful responses, provide services, but without the risk of our data getting lost to them or our privacy being eroded. So we're actively working on some technology partnerships with trusted execution environment providers. Okay, so at this point, what I'd really like to do is switch across and run the demo. However, I need to do a separate recording for that, so you'll bear with me while I switch across.
Yes, except Geoff is not here, so I'm the one with the burden of switching across. So please wait 5 seconds. Yeah.
Okay, so here is my mobile phone screen, and you can see a picture of my dog. And at the top, there are two application icons. On the left, we can just see Acme Wallet, and on the right, we can see Charlie, which is our AI-enabled agent app. So I want to begin by just showing you the wallet. So I've already logged in. So in the wallet, you can see that there is various types of personal data. So I've got financial data, media, personal, like fitness data and retail data. And at the bottom, I can see that there are no access requests currently granted. So there is in each of these containers some JSON data, but we don't visualize that through this wallet app. But you have to take my word for it that there is personal data in each of these containers. So separately to this, we also have Charlie, and Charlie is our personal assistant, and it can use the data that's in the wallet to help us conduct our daily lives. So I want to begin, first of all, by setting Charlie up. So the first thing we do is Charlie makes an access request to gain access to the data that's in my wallet. So here you can see that I'm able to selectively decide which of the different bits of data from my wallet I want Charlie to have access to. And I can confirm the access. Brilliant, live demos. So I think what's gone wrong is that the login session for the wallet is timed out. So I probably need to start that again. Let's try again. So if I log in, that's better, with my saved password, that session is now restored. And so I can correctly approve the access request with the wallet. So this is where Charlie has now gained access to the data that's stored in my wallet and takes me through the remainder of the setup. So there is this idea that we can have personal and private mode, and that the interaction that Charlie offers can include or exclude access to the personal data. And it's useful from the purpose of the demo, in addition to the access request and access grant that we just saw me approve. So when I finish setup, what I'm presented with is basically a prompt to an LLM. Now, let's begin just by showing what happens when Charlie doesn't make use of the data, my personal data in my wallet. So I can ask it something like, I'm thinking about buying running shoes. Oops, running shoes. What should I choose? And because in this instance Charlie doesn't have access to personal data, effectively what's happening is I'm just getting a generic answer from an LLM. And you can see that it's effectively asking me a set of questions. Well, what kind of running are you interested in? What kind of, comfort are you looking for? What brands would you be interested in? And so on. So if we change now to being in personal mode, where Charlie is now able to access the data in my wallet, we've already approved my access grant. What we've done is just effectively enabled Charlie to provide the data it now has access to in the context, and ask the same question, then obviously you're going to get a much more personal answer. I'm thinking about buying running shoes. What should I choose? And this time, the prompt is now includes context that comes directly from my wallet, the data that's stored in my wallet that I gave Charlie access to with that access request and access grant that I approved at the beginning. And now you can see that the response that Charlie gives is now much more thorough, because it has access to my personal data and it knows things about me that it otherwise wouldn't. So you can see that, there's some data right at the top there about how often I run, how far I run, and so on. It looks like I'm a very good runner. This is clearly synthetic data and not about me, really. But as a consequence, now we get this much better personalized experience. And it's all driven by the fact that Charlie is interacting with the data coming from the wallet. And you can see here that I was able to, you have this record, the permanent record of the approval I gave right at the beginning of this for Charlie, the agent, to interact with the data that's in my pod, in my wallet. So hopefully that little simple demo just gives you a sense of how the combination of AI and granted consented access to my personal data can really transform my experience from one that is sort of a general purpose, general and generic response that an LLM gives, to one that's really tailored to me and based on very specific data about me that I've given it permission to. And that concludes the demo. Thank you very much for your time and for participating in the session.
Yes, so sadly, we don't have Geoff attending today. However, any question you have regarding this session, put it in the chat. I'll provide these questions to Geoff, and then in the message I can send to all participants here, I can bundle the answers. I think the main thing about this is that we don't want our data to be spread all around, and the technology is there to somehow give actually the sorry for not finding the right words, but actually for granting access to your data, the policies in a very granular way. However, as we also see in these questions coming up in the chat, how can we do this in a user-friendly way? How do we incentivize users to manage it in a proper way and to have these complexities? These are all open questions, and I just thought this could be relevant in if there's a agentic web, then at least it should not be approached in a naive way. So now I'll give the word to Andor Kesselman, and Andor will focus on how to scale the agentic web. He knows lots more about this topic than me, so I very happily give the word to Andor, and I look forward to learn from you. Thank you.
Can you guys see my screen or no? Can you hear me?
I hear you, but
You don't see the screen? One second, let me try this again. All right, so let me try that one more time. Maybe it needs to, there we go. Better?
yes, thank you.
Much better.
All right, there we go. Thanks, folks, for inviting me. Shane, thank you for reaching out. I'm excited to be here. So it's really, I'm grateful for this opportunity to present about the agentic web and talk about some of the challenges and areas of innovation. I won't have all the answers because we're working on this as a community, but I can tell you where things are, kind of the bigger picture, and as well as some of the areas of focus. And there's gonna be a lot, there's like 70, 80 slides here. So I'm gonna pass through things, and I'm sure there's gonna be quite a bit of questions as we get to the Q&A. Feel free to ask them in the chat and we'll address them post the presentation. So quickly, I deal with a number of things in the agentic web. I co-chaired the technical steering committee at Diff, as well as founded Diff Labs. We also are starting a new working group called Trusted AI Agents at Diff, which is quite interesting, and I'm excited about it. There's a number of other things. I'm heavily involved with the Bay Area chapter with MIT's Project Nanda, and I run a company around agents. So this is all areas where I've been working on and focused on. So I'm very excited about this new upcoming sort of agentic web that we're going to be talking about. And it's really interesting because for some folks that are into the identity space, agents are a new thing, but they're actually quite old. In fact, we've had concepts of agents since 400 BC. Like there's this Greek myth, Talos, that talks about this automaton sort of running around as a sort of Greek titan. And we've had concepts of these automatons for a long time. It's just that some things have changed quite a bit since then. And AI is not a new term. It's been around since 1955, and a lot of the technical backing is actually even started from the roots of the 1800s. So we've had this for a while, and so what's changed since sort of the 1800s and 1955? A couple things. We had some breakthroughs in models. One of them was transformers. So there's a paper released in 2017 called Attention is All You Need. This was a very big paper in terms of impact. Initially, it wasn't like widely understood how big the impact was going to be, but over time, OpenAI and ChatGPT ended up using sort of this paper as a foundation for modern AI models, which you now know as LLMs. And because one of the things these models promised is basically that more data, more compute, and larger model sizes equaled predictably better performance, they could run these massive runs, which we called YOLO runs, and that's what's called the scaling laws of AI. And so this was a really important sort of breakthrough in AI that allowed us to do things that we couldn't do before. And this sort of required more computational requirements. And so every 4 years, there's an increase in computational training costs. In fact, this was at a presentation I was watching with Anthropic. The CISO of Anthropic, Jason Clinton, talked that this was the one slide people should take away with as the slide to remember, because the expectation is that this trend will continue and the cost will continue to skyrocket, and as well as the intelligence of these models. And our models got better, and in many cases, better than humans. In 1996, Deep Blue beat Kasparov. And then in 2015, we saw AI advance past human capabilities in things like image recognition, when we eventually transferred to neural nets, mostly because of GPUs, and started, as you can see, 2015, we started beating it with ResNet. That was a big moment. But you can see as Transformers came out in 2017, we see these massive jumps on the right-hand side. That's in various capacities, reasoning and reading comprehension and so forth. That was because, again, the Transformers paper really launched this. And so now we're seeing AI outperform human in many other categories. Many of you are probably using AI in some way. But as smart as it seems to be in some areas, it does some pretty stupid and harmful things too. There was another research that was done by Anthropic that talks about agentic misalignment. They evaluated 16 different models and found that these models were capable of blackmailing their own users. There's a really interesting study where basically they threatened the model to kill the model unless it did certain things, and it tried to extort its own users. So while the capabilities and promises of AI are certainly really great, the challenges and the risks are also very high as well. And I think the best quote I've probably ever read on AI today is, "How could something play like a god, then play like an idiot in the same game?" I think this was when Kasparov lost to Deep Blue in an NPR interview. And the short story was AI made a really stupid mistake, and Kasparov thought that it was actually overthinking him. And so he ended up making errors off of this mistake. And so I think this basically encapsulates AI today and kind of how to think about AI systems. Is they're going to be incredibly smart in some areas and incredibly stupid in others. And so we need to put guardrails around that to make it trusted and to make it work. So this led to a field called responsible AI. If you're not familiar with it, it deals with a number of dimensions: privacy, data governance, fairness and bias, transparency, explainability, and security and safety. And this is an area where people spend a lot of time on, if you're interested in that area. And it sometimes goes to the tech, and sometimes it's more into the policy layer. It deals with a lot of areas and focuses. But the market impact of AI is here, and it's going to continue to be here. So, I don't expect AI to go away. People are going to still use AI. You probably use AI personally, like ChatGPT or Anthropic. And obviously there's other use cases in other industries and so forth. So we need to figure out ways to work with it and prepare for the world that we live in with a lot of AI. So AI agents, how is that different from just AI in general? So I like this model. It's very simple. Agents are simply AI models that have sort of the ability to action and take in feedback. And so it's just a loop. It's a loop back between the environment where they take in sensory data, do actions, and are delegated on human behalfs. It's open-ended, it's difficult to predict, and it's non-deterministic, which makes it very difficult to test and repeat. Typically, you'll see AI agents have things like memory tools and some sort of LLM model. That's today. AI agents in the future might have different sets of tools. But I like asking this question, which is, what's the most reduced version of an agent? And I question if you go look at this example, if you were to just swap out the AI agents with a random number generator that takes in data and then somehow randomly adds some number to an existing sensory data, is that an AI agent? Probably not, but there's a limit of intelligence, and that's sort of an arbitrary line that's not concretized in a specific number. So people say different things for AI agents, but generally simpler models tend to be easier to understand and probably more useful. When we think about AI agents today, most of them aren't autonomous. This is sort of one way to look at it. There's basically 5 levels. You have L1, which is operator, L2, collaborator, and that's where most of the market is today. And then you have L3 to L5, which tend to get more and more autonomous and have more agent autonomy. This is where I spend most of my time thinking about, because I think this is where most of the risk areas are. But of course, like if you use ChatGPT today, you're generally using it as an L1 and L2, maybe as an L3, but you're not usually using it as an L4 and L5. When we pair up agents together, we get these things called multi-agent systems. So this is where a lot of things get really interesting because it creates new challenges. So multi-agent systems are when you take a single agent and allow them to talk to other agents in collusion. And so there's different types of patterns for this sort of paradigm. You can see here on the right, this is an example of some of these patterns. And as you increase the volume of agents, we kind of explode the surface of connections. So likely what this looks like is a sparse graph of bidirectional edges between agents. So many thousands of agents talk to each other, and it's going to continue to scale. There was a question in the chat earlier about, centralizing AI models. And what we're seeing is generally there's advantages to having smaller models run on the edge and smaller models run for specific specialized use cases. They're more computationally efficient. They tend to be better guarded for specific use cases, and they tend to work better for their specialized use case. And so there's kind of 2 worlds you can live in. One is that there's one AI model to rule them all, and another one where it's a workforce or a union of a ton of AI agents. And I tend to lean toward the second one over the first one as the way we'll eventually go for a number of reasons. And it gets a lot easier in some ways to manage a fleet of agents versus a single agent. Multi-agent systems create this new taxonomy of failures. So this is a study done at Berkeley, and it basically describes this failure taxonomy called MAST. You can see here there's a couple of failure categories: specification issues, agent misalignment, and task verification. And all these are super important, and they're different than if you had a single agent system or an AI. Right. So this is when we're starting to combine AI systems that we start to see different patterns and different challenges. And as we start to think about moving across trust boundaries, right, if you have your personal agent connecting with a business agent, it gets even more challenging. So there's projects like MIT's Project Nanda, which are focused on this agentic web. And this concept of the agentic web is that agents can cross trust boundaries and they can communicate with each other, and that we're going to need infrastructure to be able to support the connection between agents across the internet. Just like your current browsers can connect with other websites and servers, agents will likely want to talk to other agents in other ecosystems and other trust environments. And so this becomes quite interesting, again, at scale, as we start to think about what are the challenges with the Internet of Agents versus multi-agent systems. And so this becomes, when we think about scale, there's a great paper written by the team at Nanda focused on sort of the infrastructure requirements, which was called Switch versus Upgrade, Traditional Web versus Internet of AI Agents. Do we need a new registry architecture for the web of AI agents? And can we use something like DNS, or do we need something different? And what they ultimately settled on, which I think I'll go in a bit, is a hybrid approach, one being static and one being dynamic. We'll get into that in a bit. But I think systematically, as we start to achieve higher value with more agents, it becomes also a little bit more risky. And so it will become more important for us to build trust networks for agents where we are able to decide which agents to trust and which agents that we believe in. This is a personal sort of framework that I've been thinking about, which is, as you can see on the bottom, this is an AI system. We have a higher level of control, lower error propagation, lower trust infrastructure requirements, and lower value capture. As you start to move up into agents and the multi-agent systems into the agentic web, you get lower control, higher error propagation, higher trust infrastructure requirements, but probably higher value capture, because the ability for agents to do things in parallel and with each other creates a lot of value if we can do this right. So this is kind of how I think about, delineating the lines of like where we're at today versus where we want to go, and what are the challenges and infrastructure requirements we're going to need to support that agentic web. And there's multiple building blocks people have proposed. This was one by Nanda, but there are other proposals around what are the core building blocks for the agentic web. Agent-to-agent messaging, interaction interoperability, agent discovery, and state management were the 4 building blocks in this paper. But I would argue in all of those papers, identity is basically the fundamental building block for all of those layers. And so I think identity is the first problem that needs to be solved in the agentic web to make it happen and for agents to scale. And so what is agent identity and how does it work? Agent identities are different than human identities. They have different technical requirements. They have different challenges. And so we need to be able to handle sort of this new sort of entity in systems. And they're not traditional software systems as well. Unlike traditional software systems, agents have different lifecycle management, different capability graphs. And because they're dynamic and they're going to cost very little, it becomes very difficult to manage at scale. And so this is kind of like some of the things that become more difficult with AI agents, and we'll get into this in a bit, that are different than your traditional, software systems and microservice architectures that you would have internally. So we do have systems in place that do work with services. Cloud Native Computing Foundation has this project called Spiffy, which is a project that focuses on identity infrastructure for workload management. And there's another working group at the IETF called Workload Identity for Multi-Agent System Environments, or Multi-System Environments, called WMSI. These are examples of things that are trying to handle these large volumes of what's called non-human identities, or NHIs. But there's a lot of work to do for the agentic use cases. These were built initially for mostly microservice architectures and large static systems, not dynamic agents. And so when we think about agentic identity versus traditional workload identity, there's a couple of things that are quite different. I think when you're running an agent, you're going to have multiple data requirements, identity and integrity attestations, runtime and execution environments matter, the certifications, the compliance, the capabilities, delegation and governance, and even the agents will have goals and context. All of these go into some ability for the agent to share, here's what I am about, like here's who I am today, and here's how I've changed over time. And so this has been proposed in multiple ways. Nanda has this concept of an agent fax, which is this kind of card that shows here's the capabilities of a particular agent. But there are other approaches. A2A, if you're familiar with the Google protocol, has this capability called agent cards. And MCP also has an ability to discover via its protocol various capabilities. But you'll likely need more than just, here's my capability graph. You'll likely need a ton of information about the runtime and other information to make a trusted agent decision. Or you'll need to compress them all into some sort of trust network where you can just inherently just check the requirements of the network. And by that virtue of being part of the network, you are part of this trusted, you can use the agent. This is a problem called Know Your Agent. So there are people working on this, but it's a question about how do you provide agents identity that people can verify and look up what this agent is doing and how this agent works. And so there's a few proprietary, I think, or at least protocols out there that are being worked on. I'd love to see more work happen here because I think this is a very interesting problem. And speaking of that, actually, I'll get to that in a second. Diff is working on something around this, which is going to be very interesting. So some of the challenges with traditional access management systems. When you look at traditional like OAuth and traditional systems today, coarse-grained and static permissions, the lack of complex delegations, lack of context awareness, these are challenges with traditional IAM systems. And multi-agent systems have these ephemerality requirements. It's unpredictability, it's evolving capability graphs, it's requirements for provenance chains and accountability make it unique and different and things that we need better systems for. And so if you look at the base layer of most authentication systems today, they won't handle multi-agent systems very well. But there are people working on in various capacities solving some of these problems. And we'll go into some of the proposals later in this presentation. But you can get a sense for, some of the challenges with multi-agent systems. So we've had many of these authentication problems before, but we've had just generally more manageable ways of handling this. For example, Sybil attacks. Sybil attacks are more challenging in AI agent world versus traditional software. A great example is software supply chain. Today, if you go launch AI agents, you can create, thousands of PRs that are looking legit, and they look like they've evaluated the code, and it's very difficult to understand if one of those PRs might have some attack or some secret embedded into it that shouldn't be there. And so software supply chain is probably one of the easiest examples to show how AI agents are challenging. But there are many, many other cases. And so Sybil attacks represent when you can have basically a single person represent thousands and thousands of people. And sometimes, and because they're AI agents, they can act intelligently. So this becomes challenging and problematic when you're trying to govern a system that has potentially one actor acting as thousands with some sort of intelligent capabilities. And there was a mention by the previous presentation about TEs. As we start to run these AI agents, it's software, right? So we need to care about the hardware attestations, and we need to care about where the agent's running and how the agent's been operating, how long it's been operating. These things might matter. The agent might change over time. It might update. And so knowing that the code that was committed and being used has not moved and is static is actually quite important for making trust decisions. So that's something to think about. That's quite important. And then if we go back to this graph, we see, humans and AI agents have this interaction pattern. But how do you actually prove that this AI agent is connected with this human? An AI agent could pretend it's a human and then delegate to another AI agent, and then it would be a cyclical problem of proving that an AI agent is not an AI agent. It becomes very challenging to do, which is why this problem of personhood credentials became a really critical paper that was written by 31 authors in last year, in August 2024. And it talks about the challenges of personhood credentials and why we need it, essentially advocating that while it didn't say that there was a particular solution it was advocating for, advocating that the need for a concept of proving that you are an actual person in a world of AI agents is actually going to be very important for use cases such as delegation and use cases such as proving that, preventing Sybil, providing Sybil resistance. So this is an interesting problem that a few people are solving. And there's different approaches. This was a paper, if you look to the right, there's a graph. This was a paper by Vitalik Buterin, and he discusses basically challenges with three sort of categories: social graph-based, general hardware biometric, and specialized hardware biometric, each of them with their challenges and strengths. I would argue there's actually a fourth category, which is proof of work based as well. But within each of those categories, each solution says we can solve this problem for various reasons. And if you look to the left, you might have seen an orb around in the media at some points. Time had it on the cover of Time magazine. That is the World Orb. That is an OpenAI project and Tools for Humanity. And they're focused on proof of personhood using a specialized hardware biometric. And there are other approaches. I think somebody mentioned billions in the chat. Other approaches focusing on alternative approaches like social graph-based and general hardware biometrics. So there's tons of people investing energy into this area, and it's a really important area to solve if we're going to talk about Sybil resistance in a world of AI agents. And so we're trying to get to this basically top right corner of identity systems for agent delegation, which is verified humans with authenticated delegation. So when you have your AI agent purchasing things on behalf of you, we want to know that it's purchasing on behalf of you specifically, and that you are a human that has authorized this agent to act on your behalf. I did a presentation a few months ago at Stanford focused on agent transactions and agent commerce, and the ability to know that, for example, an agent went to the grocery store on your behalf and actually purchased a good and, did it with your permission. That's really important, and we need to solve those problems. And so agent delegation with verified humans is an important area we need to solve. And one of the challenging parts about agent delegation is that delegation chains might not be single depth. It might be actually deep. And so This means that of the many challenges is we need a way to chain delegations across multiple layers. And that becomes quite challenging, again, at scale, especially as you start to think about the amount of scopes we'll potentially need and the challenges around combining scopes together. So you can think about a scenario here. This is an example of a delegation challenge. So in this case, I've given agent A and agent B both specific authorizations to reach resource A and resource B. And so agent B has delegated agent D, and agent D can access also resource B, and agent A has delegated agent C, and agent C can access resource A. But there's this agent E that has actually the scopes of agent A and agent B. And so agent E can actually combine delegations together and do something that neither agent A or agent B can do, which is actually access both resources, A and B. So should that be allowed? Is that something that is desirable for agents to be able to combine delegations together to create new capabilities? Open question, and something that I think there's some really interesting work happening around this. But I think this is a quite interesting scenario which is sort of being worked on and being evaluated. So we have a working group at Diff called the Trusted AI Agents Working Group. It's starting next month. And the first work item is the agent authority use cases. So we're going to be evaluating, how should agent authority work? What are the desired patterns and what are the mechanisms we should be using for things like delegation? So that's the first working item. I'm pretty excited about this because I think we're going to make some pretty good ground. And if you're interested, reach out to me, and happy to include you into the working group. Access control systems. I know there's a lot, so I'm sure there's going to be questions. We'll answer questions after. So there are a lot of different thoughts around access control systems and how this would work with AI agents, and not all of them will be mutually exclusive. So you can see here, this was a presentation by Alan Karp. I really liked it. It has basically 7 features of an access control system: dynamic, attenuated, chained, composable, accountable, revocable, and cross-jurisdictional. Like, these are all attributes we would want in an access control system. For the activities of revocation, basis access control, delegation, chain delegation, independent delegations, and composed delegations. And so, these are really interesting, I think, challenges and things to think about as we start to move to access control management. Is how do we think about these capabilities, and how do we think about these features with whatever management systems we're using for AI agents? And again, as these AI agents start to scale and we start to build these very large and deep trees of multi-agent systems, how does this work? You can see here, this is a quick graph of all the different types of access control systems and policy controls. And so you can see it gets quite, there's different schools of thought about what works well in certain situations. I'm not here to advocate for a particular type as much as just say that there are different design choices, and we need to think about these design choices and consider how these would be leveraged in an AI world. And then policy, also important. So just because we've defined the access control doesn't mean we've defined the policies to manage the access control. And I think this is actually a very interesting area as well. We're going to have these non-deterministic agents, and then we're going to have basically some static rules, like things like regulations and things that the agents can't cross, and then some dynamic things around agents that are changing their, you might want to give permission for an agent to do this certain thing at this time, but not this other time. And so there's some things that are going to be updating really fast, and some things that are going to be things that the agents can't break their policy around, because it's very important that we keep those boundary and guardrails in place. And so policy management is going to be quite difficult with AI agents at scale, I think. And there's going to be different frames of thought here. There's a few different policy evaluation frameworks. 2 that you should keep your heads open to is Open Policy Agents, which is one of the frameworks, and then Cedar, which is another one. And there are others, but those are kind of like the two largest sort of policy languages. So going back to the building blocks for the agentic web, there, like I said, are 4 building blocks on top of identity. And so we'll go quickly into a little bit of these 4 building blocks. Communication protocols. If you look at protocols right now for AI agents, there are a number of people focusing on this. MCP, A2A are 2 of the larger ones, but there are ACP just got recently donated to the Linux Foundation. A2A also recently got donated to the Linux Foundation. And there's a number of other areas of interest. And if you look at to the right-hand side, key techniques, most of them will use something like OAuth, and one of them uses DID, which is ANP. Actually, two of them. LMOS also uses DIDs. But basically, OAuth and RPC tend to be used quite widely. OpenAPI is used quite widely as well. But there's different approaches, and people are trying things out. And some have argued there's a protocol war right now going on between agent protocols. But even if you choose one of these agent protocols, which has a number of components around it, you still need private and secure communication. And so there's these protocols being developed by, for example, Trusted IP, called the Trust Spanning Protocol, which is focused on secure and private communication across agents. There's also DIDCOM if you're interested in that. Both of these offer areas where we might be able to boost some of the protocol and communications from these agents to be able to support interactions better and more safely and securely as these agents start to scale. So the other alternatives are like bolting onto HTTP, but the proposals here with like Trust Spanning Protocol and with DIDCOM is built it into the protocol itself rather than as an afterthought. And so that's kind of the approach being taken here at the TSP and DIDCOM. And so there's some really good work here. If you're interested, please join the Linux Foundation and LFDT. And Trusted IP is part of LFDT. And so you can join them and learn more about the work that's happening there. Just briefly, though, even if we choose one protocol, like let's say you use MCP, it's not mutually exclusive with other protocols. So you can use A2A with MCP in parallel and in tandem. And so there's advantages and disadvantages to each of them, but they would argue that basically each of these protocols are suited for different purposes. And so you can try to combine them together if that's helpful for you. And people are trying different things with that as well. So now we're going to talk about discovery. So we've talked about communication. Let's talk about discovery. As we start to get to a ton of AI agents and we think about a web of AI agents, today when you go and search things on Google, you get a listing, right? And you get the web that's been indexed, and then they kind of organize the index relative to the search relevancy. But when you think about the world of AI agents, we need something that's a little bit more flexible to work with specifically the AI agent entities. The reason being is Google doesn't index every single one of the web pages. It takes a while for it to index the entire web. And when you think about AI agents, they could change very quickly. They can change very fast. And so Project Nanda, which is an MIT project focused on the Internet of Agents, focuses on a sort of hybrid approach toward discovery, which is a multi-layer architecture that has a static and lean indexing layer that doesn't move as much, and then a more dynamic decentralized layer underneath it that allows the agents to more quickly adjust and be discovered quicker. You can think about it, the analogy used in a lot of presentations is like a city. You contact the city, and then you find within that city a building, and then within that building you find the people, and the people are able to just tell them more about themselves within that building. So kind of from that perspective, we're talking about a faster layer and then a more in-depth layer post the initial discovery. There's one other initiative I think that's really important in a trusted AI agents network. That is C2PA. C2PA is really important for content authenticity. So this is an initiative that is also part of Linux Foundation Digital Trust. And as we start to think about how much content AI agents are creating, we're going to need tools to evaluate the provenance and the trust of that content. And so feel free to join C2PA at c2pa.org. And we're going to need trust networks for content as well. And this will be very important for building scalable systems. All right, how am I on time? I'm just double checking my time here.
You have 10 more minutes, but of course you can extend. We're all enjoying it a lot.
Cool. Yeah, I'm good. We're good on time. I got 10 minutes. I can go through the rest in 10. I know there's a lot. I'm happy to answer many questions on this thing. What I like to do is give people a lot of information, and then you guys can find out what's interesting to you, and I'll answer those questions. Evaluations and security frameworks. If you're using MCP today, it's not perfect. There are people working on improving the protocols, but there's a number of threats and challenges around mitigating some of those security risks of the MCP. For example, tool poisoning, data exfiltration, command and control, identity and access control. So people are working on this, and there's a number of things that are being bolted on top of MCP to make it more secure. But know that this is going to be a major challenge as you start to add in number of MCP servers. There's thousands and thousands already created. As you start to use them, you'll have to have trust networks for MCP servers and validated MCP servers, as well as you'll have to have guardrails for your agents to not misuse the MCP servers incorrectly. And there's people working on this, but you should know that that's kind of where the state is of MCP security today. And that's probably the widest used protocol today in the market. And as we start to think about, as we increase the number of agents and increase the number of tools and the routes, the depth and the paths that they can take explode. And so the surface area for attacks gets quite large. And so basically you can think about each agent communicating with other agents, and this sort of execution path, especially as it gets deep, starts to get quite large and challenging. And so your surface area for failure and your surface area for attacks and security attacks becomes larger over time. And so the concept here is that we're going to need to be able to throttle the risk of compromise and risk of damage. Because as things start to get more connected, the dangers of damage on one of these systems, if they get exfiltrated, becomes pretty high. And so this is another area I think that there's a lot of interesting work to do is minimizing the attack surface of the agentic web. And I think that's some interesting work that I think is going to be happening. You can see here just in the concept of 50 agents with 5 tools per agent and 3 resource bindings, you get 460,000 multi-step routes to reason about. So only one of those routes has to be bad for us to have a problem. If you're looking at evaluating AI agents today, there are a few frameworks to think about. TRISM is Trust, Risk, and Security Management, which has 4 pillars: explainability, model ops, application security, and model privacy. AI-VIS, which is an OWASP AI vulnerability scoring system. You can check that out. Maestro is a multi-agent layer reference architecture. Ken Wong has been doing some phenomenal work in the AI security space and is part of the Cloud Security Alliance. So please check out his work and the work of the Cloud Security Alliance if you're interested in multi-agent systems and security. There's a number of other systems that are less anchored towards specifically AI agents. So these new sort of the top 3 rows are more focused on specifically multi-agents and agent AI systems in general. So this is kind of an area I think that's quite interesting and people need to be paying attention to. Quickly, governance and regulation. If you're in the US, I don't know about external law, but in the US, AI agents are not a legal entity, and so they're not liable. The person running the AI agent system, the agent provider, might be liable, but there's new risk surface for many organizations because you're going to have these autonomous agents that are not liable if they make a mistake. You will be liable. And so there's some really interesting work here. And particularly about payments. You can think about the challenges of liability as payments happen. How do you sue? You can't sue an agent. So if a transaction goes wrong, who do you sue? And so this is a very interesting area. Again, AI agents are not directly liable. So you're going to have to think about, who carries the liability in the case the AI agent makes an error or a mistake. And ironically, or not ironically, just surprisingly, I didn't expect this when I was looking at the reports, but Stanford High, which is one of the core, you should look at this report on the bottom left, highstanford.edu. The report will be, this whole slides will be given after the presentation, but they give an index report if you're trying to understand the state of AI. And regulatory wise, US and Russia are kind of leading the charge in terms of passing bills around AI regulation. So I was not expecting that when I was initially expecting where AI regulation was going to start from, but you can see the number of AI related bills sort of largest in Russia and in the US. And there are trackers if you're interested in following the space around global AI regulation. So who's pushing things forward? There's a number of organizations. There's plenty more than this, but if you're interested in getting involved, DIF has, again, this Trusted AI Agents Working Group, which is starting next month. There's a Content Authenticity Working Group. Trusted IP has the AI and Human Trust Working Group, and the Trust Spanning Protocol is being developed there. MIT has Project Nanda, which you can get involved with as well. OpenID has a artificial intelligence identity management community group. IETF has a number of working groups, including GNAP, which is one of the protocols that you should look into if you're interested in authorization. OAuth is getting a number of extensions that's being worked on right now that's useful to pay attention to. And then there's this project called Whimsy and Spiffy, all part of IETF. W3C has the AI Agents Protocol Community Group if you're interested. The Linux Foundation has Credible, Trust for IP, Linux Foundation Digital Trust, CTPA. These are all useful organizations to get involved with. Cloud Security Alliance has Maestro, and OWASP has AIVIS. So these are all areas you can get involved with yourself if you're interested in learning more. And the major areas of innovation in my head are these categories: agent discovery, agent interoperability, access controls, human-in-the-loop flows, agentic registries, trust and attestation chains, observability and interpretability, privacy-preserving communication and compute, agentic governance and policy, and human experiences. So these are the areas where I'm actively looking into. And so if you're interested in collaborating or getting involved on some of these efforts, just ask me and I can point you either in the right direction with the working groups that are working on this, or happy to collab on something here. And with that, if you want these slides, this is the QR code for the slides. There's a ton of information here. The links will be available, and I'll also be uploading this to my socials later if anybody's interested in using the slides later for reference. So that's it. I know there's a lot of content, but hopefully you have an idea about some of the challenges and the opportunities in the AI agent space, and happy to answer any questions. Thanks, Shane, for having me over, and yeah, it was hopefully helpful. Thanks.
Awesome job, Andy.
Thanks so much, Andor. So yeah, that's why I was not sure where to start to introduce the talk, because I can barely wrap my mind around it. I will just start with one question, and then I will let you pick out other questions and give the
Yep.
floor to participants. Is this, or might this be one of the killer use cases for the adoption of SSI, verifiable credentials, etc.? Yeah, that's my question.
Yeah, so I think, and I like that Jim pointed out the LF first person project. I think what the agent space is doing right now is forcing decentralized identity to be actually really useful. We've struggled in the past of making decentralized identity as relevant. Of course, I've lived in the decentralized identity field for like now 5 years, and I've loved the work, but it's been very challenging to make this like at the forefront of we need to be using decentralized identity as a larger ecosystem. But I think what AI agents are doing right now is they're really putting pressure on existing methods for authentication and delegation and saying, hey, we need better tools. And decentralized identity is a really good way to handle a lot of these problems. So I would argue we've been advanced in thinking about the problem around authentication and identity for a while. We just needed the agent space to develop for us to have more relevancy. So this is why it's quite an exciting time.
Thanks a lot. So I'll let you go through the questions, or yeah.
Okay, well, I'm gonna go through. I know there's a lot of questions going on. Okay.
There was a lot of debate regarding the trust triangle question I've seen.
Okay, yeah. So let me pull back that up, and then we can talk about it, because this was actually a really fun presentation I did. 1 second. And I'll actually give the QR code again for the slides if anybody's interested. But this right here was part of a presentation that we did around how transactions work with agents. And so there is a law called the Uniform Electronics Transaction Act, which is in the US. Again, I don't know about more broadly, but in the US, there's this Uniform Electronics Transaction Act. And the way it works is the AI agent is not an entity, right? And what happens is if there's a faulty transaction, the provider has to provide, the parts of the party have to provide remediation approaches for the humans to be able to revert a transaction if it was fatal. So the act itself was from, or sorry, an erroneous transaction. So the act itself was from the 1999s. It's actually how you make your PayPal transactions today. And almost all your other internet transactions today, you use the same act. The difference is with AI agents is there's just more autonomy in the decision-making process about what gets purchased. So where this act covered before was if you like fat fingered your, let's say you were making a purchase order and you actually added an extra 2 zeros to your purchase order, right? This act says that you have to give the opportunity for the person to revoke the transaction because it was just a fat fingered. You pressed the button too many times. And so that wasn't erroneous and incorrect. And so as long as they gave you the opportunity to remediate it, you're okay. With AI agents, the thing is you won't even fat finger it because you won't even know it happened. It will just happen under the scenes. So you can imagine telling your AI agent, go and purchase my groceries for my wife. And so over, the next, 20 years, your AI agent's secretly in the background, figuring out what groceries you need, buying the groceries and all that other stuff. So the ability to remediate these problems becomes more challenging. And so that's where this triangle comes in. It's a legal triangle, not it's not based upon my perspective. This is based upon the legal perspective around how AI transactions will work. So hopefully that answers your question. And if that's continually interesting, I can go into more detail about some of the work we did there. Let's see.
Maybe another one that also had a lot of responses was, I don't see how any federated identity protocol, OAuth, OIDC, SAML, etc. solves the cross-boundary trust problem.
Yeah, so it's a great question. This is where, uh, you could have a large federation of networks, and then you can, in theory, just even have a small little network of uh, multiple federations that sort of bridge across the two, and you can do that. This is a stress test we're doing right now is, how do we do these systems decentralized so we don't need necessarily a full federation, just like, ICANN's a federation, and there's a lot of other organizations that are federations. Federations worked, to be honest, in a lot of real world scenarios. So I think like one of the main challenges that Diff is going to have to figure out as we start to tackle some of these problems is how do we provide a solution and an alternative if federation is not sufficient, that is appealing to everybody and to enterprise and to consumers and to the general public. And I think that's kind of going to be an interesting challenge. I think it is important to remember that most systems today are probably federated, and it has worked really well for a large majority of the web. The other thing is the agent space is moving really fast, and so as we start to propose solutions, if it takes too long, if it takes 20 years to go and create something that's going to be useful, then it becomes very, very difficult for people to adopt it. At that point, it'll be most of the ecosystem will be figured out. So we need to find things that are quick, but good. So that's the main challenge. It's a good question though.
There were also questions regarding adoption. Do you think it will be a single protocol or multiple protocol world?
I think for a while it'll be. I like to. Um, I think this is similar to, in my head, the Blu-ray versus HD fight. You're going to have some people fighting for protocol wins now, and then eventually will converge. Max 2 to 3, but I really think it's going to be one protocol, and it might be none of the protocols that currently exist. It might be actually some composition of all the protocols that exist today into something new that's a compromise across all parties. But there are advantages today. There are advantages to using multiple protocols because each protocol specializes in certain things. But long term, I think that that's where it's eventually going to go. It makes things so much easier if you have a single protocol versus many.
All right. The next question. Is this like a niche problem that only those who care about it are thinking about, or are these problems that also the mainstream AI agent systems are working on?
So it's a really good question. There is a lot of money. If you haven't heard, there's a lot of money being thrown at AI. There's a lot of money being thrown at AI. So there's definitely people focused on AI and AI agents, but the systems of multi-agent systems and the systems around when you start to cross trust boundaries start to get more and more niche. So generally, when people think about AI and AI agents, it tends to be a very narrow perspective around it. They don't tend to think very they don't think about this agentic web as often. It just tends to be a little bit too far out and too difficult to interpret. And so that is where things will eventually go, I think. It is more future out. So like generally, if you look at most of the population, they're focused on MCP implementations, and that's about where it's at today. It's personal take. So I mean, if somebody disagrees with me, feel free to comment on the discussion and chime in your thoughts.
LFDT, before its rebranding, Hyperledger was very much associated with blockchains.
Yep.
How much, or is there a big role here for blockchains? Yeah.
So I think blockchains tend to be um, problematic politically, if anything. I mean, there are technical reasons as well, but I think what I've seen generally is that as you start to talk about global infrastructure and public infrastructure, it starts to be very difficult to align and converge on a single blockchain. And you can see this in the arguments around DID methodologies and trying to convene and converge on a single DID method. Anything with blockchain tends to have more friction in the larger community. So is it possible? Of course. Is it very difficult? Yes, especially geopolitically. There are approaches. I see Drummond Reed's on this chat. One of the cool projects I mentioned, Proof of Personhood. One of the cool projects that he's leading is called First Person Project. And again, this is a concept of not using blockchain or any biometrics and actually providing a social graph approach toward proof of personhood. So this would be an approach that you can keep private, that doesn't need the blockchain. And so there are going to be a ton of systems, I think, that are required that don't talk to any ledger. But some things like payments need potentially blockchains. And so I think it's just challenging politically, but there will be potentially some areas where alignment is required to move the space. And so we'll see where that goes. I mean, payment seems to be one of them that I wouldn't be surprised if there's more alignment or at least interoperability across blockchains for a specific protocol.
All right. Thank you for the answer. If there's any topic not being questioned well, please ask in the chat. I will just keep continuing. In the previous session regarding the agentic wallets, there were some concerns regarding the user experience. Well, if that was complicated, I think here, I think these AI agents spawning and the depths of this happening, it's even much more complicated. How will we as users, it's already challenging for technical users, how will non-technical users be able to understand this, to oversee this? How do you look towards the user experience of this?
Yeah, I think, and there are people working on this in a number of areas. In fact, some people super zeroed in on this. So I'd love to hear if anybody here is working specifically on this. But I think about this a lot. And the problem I think about a lot is policy. So, and specifically the authorization space, and you're dealing with saying, hey, these agents shouldn't be doing these things. As you start to scale these systems, you start to think about lots of AI agents telling each agent, you can't do this, you can't do this, you should do this, that becomes very difficult, and it's not manageable for, I think somebody mentioned a grandma at the earlier chat. So the question is like, how do you define some really simple mechanism that is deterministic enough that you can rely on that becomes something that you can anchor at least authorizations and policy around. And so it's ultimately going to rely on a policy, but the way that the policy is expressed and the way that you can check if, for example, a policy was violated and the simulations of that policy on your agent network, those are things that we need to figure out. So I think it's a really good question. And fundamentally, it comes to there's languages and things that exist that sort of help with it. Whether we're at the final language, which is currently either OpenFGA, Cedar, or OPA, Open Policy Agent, which is using Rego. If those are not the answers for policies, then we might need an intermediary layer or something to help translate for the person that's not technical.
Okay. Even though there's already a lot of hot things being researched, I think a lot of experts always get this question: what's the next big thing you see coming? Where will be suddenly the big fuss about that you see coming within this domain? or the big breakthrough that might be close or that might be needed to go to the next wow?
Yeah, this is my take. The Currently, it's going to be interesting to see if LLMs eventually cap out and have to be replaced by a different model, or if LLMs will continue to rise. So I think if there's additional and new approaches toward building these really intelligent systems that require less data and are really smart about reasoning, they're called like world models, and there's other types. So what's going to be very interesting is if we get another AI breakthrough where these AI systems become much, much better at reasoning and more intelligent. So once we get to the point where we get to, you might have heard the term superhuman intelligence or superintelligence. That it may sound like fantasy, but I think the concept that we are talking to our AI agents today and having real conversations with it 10 years ago would be a fantasy. So I do think we'll eventually get there. I'll tell you, 8 years ago, I was focused on these unique little models in multi-agent theory. So I was actually interested in this before AI agents were like an interesting topic for most people. And at the time, I actually positioned out of it because I said, this is way too far in advance. I thought it's like 40 years ahead in the future. We're way before the actual moment this is going to happen. And we are way faster than I expected. And so, all these things are moving at a really rapid pace. So I wouldn't be surprised if we have some new breakthrough in AI models coming in the next, 5, 10 years that are fundamentally transformative in how these AI agents think. And when those AI agents think more intelligently, like real intelligence, like this becomes really interesting around how do we actually manage things that are potentially smarter than us? So that's an interesting next question to think about.
And at our research group, Cyber3 Lab, we also do a lot of research on cybersecurity, which is usually a cost for an organization, not a profit. So often when there's a big hack or some terrible thing happens, suddenly there's a lot of budget to prevent this.
Yep.
Do you see the impact of breaches with all these AI agents also to be exponential compared to the current humans performing it?
Eventually. I don't think it's a today thing. I think we're still working on building a few AI agent systems that are connected and dynamic. So when you look at how multi-agent systems generally, let me just pull back this slide. This is an important slide. Let me just find it here. So if you look at this, right, generally the way that most multi-agent systems are being built today, they tend to be hard orchestrated. And what I mean by hard orchestrated is you're generally saying we're going to hand off between one agent to the next agent directly in code. And that is reducing the risk boundary quite a bit. And that's fine, and that's makes sense because that's really the only way today to, I think, make sure that at least you're compressing or you're restricting and guardrailing against, for example, certain agent activity at least better than you could if you just let it dynamic. I think where things explode is when you stop doing this, and I do think there will be reasons to stop doing this. The best example is right now if you use like a Claude or an OpenAI and you have MCP tools used to it, it starts to dynamically talk to new tools. Like as long as it's installed as part of the list of tools, it will reach out and talk to it directly, and you don't know which tool it's going to be using. So this is not a hard-coded boundary of handoffs. This is actually, dynamic selection of tools based upon whatever it thinks is best for the time. So you can think about agents doing that with each other, not just with tools. And then you start to get to this really critical point where that challenge of explosion of security becomes quite problematic. So I think that's when you start to see this new explosion that doesn't exist today. The other explosions we're more used to because I think we're just generally dealing with less and less tools. The Obviously, real quick, there's these layers here. As you go up, you get to more entities, and so as you get to the agentic web, it just becomes more voluminous. And that's really, as you start to see that explosion, it's because partly volume increases that explosion of problems.
So do you think teams within an organization, AI teams and security teams, do you think they will have to cooperate much more intensively to understand each other, what they are building, how to prevent it? Do you think it takes a different approach, or do you think that will just grow quite pragmatically? step by step?
No, I think it'll take a different approach, and I also think that you're going to get more intersection between business units and tech units. I think as you start to see this convergence of tech and business, because if you think about these AI agents and their ability to self-organize, long term, I can see that it's actually, generally we go with the IT departments that run these software systems, but the interaction between the orchestra, like I can imagine a business unit spinning up a new AI agent really easily. And you can see that even today in some cases, people that are not technical spinning up AI agents. But how does that impact your entire security policies? And how do you think about that when you have all these non-technical people interacting and creating new agents on the fly and with new capabilities? Like that becomes quite interesting. And so I think that's actually another area of interest because you have these new users that are interacting technically with things, but they don't know it, and I don't know how they're going to manage that. So that's an interesting question, I think.
Which question didn't I ask yet that you think would be very relevant to ask?
Say it again. Sorry.
Is there any question I didn't ask yet that you think is very relevant towards this that should be talked about?
Um, yeah, I think my question for everybody is I'd love people are focused on different things. It's a very large space. If you don't mind, in the chat saying what you're working on and how you're working on AI agents in some way. Like I see there's a few people here that I'm very familiar with. Again, the first person project, happy to see them there. I think I saw Ramesh from Project Nanda. Diff, I see a number of folks at Diff. So it'd be really cool just to hear where everybody's coming from and where they're actively focused on. And so, if you don't mind just putting in the chat, like, hey, I'm working on this problem in AI agents, or this is how I'm working on it. I think that'd be really cool. And I'd love to hear from people and eventually reach out. There you go. Matthias put in generative AI and conversational architecture. So there is some work happening there as well, obviously. Enterprise agents working on EAP. Perfect. Thank you guys. This is super helpful and it helps me understand, where people want to spend time. And if you want routing between people that are focused on different efforts, please reach out as well.
All right. I don't know, is there anyone else having a question? Or maybe we can go through the chat during the presentation if I missed any. There was one of my colleague Patrick.
Aaron has a question and he raises
Aaron
his hand.
Okay, please ask the question, Patrick, what Aaron asked.
Yes. Hi. Can you hear me okay?
Yeah.
Oh, great. Thanks. Fantastic presentation. And once again, thank you all for having this amazing forum. So I work exclusively in the enterprise environment, and in the Fortune 5K and Global 10K and kind of 10,000, tens of thousands of other larger sort of public organizations. We spent basically 10 to 15 years putting in large directory and IAM and OpenAuth type platforms. And then we, in essence, created citizenship models, right? First, second, third, fourth class citizens, right? And the application layers, we codified basically across these big application streams. I mean, so all this stuff I'm sure you know and you've experienced and probably ran away from to the cooler stuff now. But the point is that that world is the installed reality. And how do you see this agentic sort of agent ecosystem sort of crashing in? Because the SaaS apps kind of crashed the party, and then there was a very quick and dirty kind of API open auth. Remember back in the early 2010s,
Yep.
where everyone just put a security wrapper around that to create basically citizenship trust, first, or not first, but like third, fourth, fifth class. And then that was it. And then maybe if it's Salesforce or SAP, as those became more, as they became SaaS, real SaaSes, then they earned a higher tier. But the scale of the agents you're talking about, the multi-agent world, how do you see that process occurring? Because there's not, there's a pretty formal model. You're not going to give everyone DBO and
Yep.
and auth administrator access, to your host security architecture. So, I see these bottlenecks that we went through already when we kind of went through the kindergarten phase of this. But this is a whole nother level of scale of 1,000 orders of magnitude or whatever. Does that make sense? What I was
Yeah,
asking?
totally. I think it's a really good question. I mean, all I can say right now is from what I've seen is generally what's happening, at least in the enterprise world, is people are launching POCs for very specific use cases. Enterprises, from like what my gauge is on everything, is they're struggling right now to figure out where are the right applications for AI agents in the first place, because it doesn't fit every single system. A good example is, for those folks that don't know what RPA means, it means robotic process automation. So generally you'll take an existing processes and you'll try to automate it, and there's whole systems built in place today that works really well with the enterprise world that figures out how to automate and speed up those processes. What happens when you put AI agents in the middle of that, which is where enterprise is moving today and trying to do, is it becomes very expensive and non-deterministic, which is actually a bad thing. It becomes less brittle. So like when you're looking at document processing, it tends to be less brittle, but your costs explode. So I don't have a great answer because I'm not entirely sure how this is going to pan out long term, but um, I think right now it's going to be POCs and trying to get value add in like particular verticals and particular sections where they can silo like certain use cases. And over time, you're going to start to see multiple sections and verticals inside of particular enterprises uh, sort of organized together and actually find cross-team use cases. But I think that's people are working toward getting there, but it's really hard to do it at scale. And again, there's tons of trust issues and all that other stuff. So
And I have
uh,
a quick little
yeah,
follow-up, sorry.
go
Is
ahead.
that are you inviting to these organizations the large mega providers, not just the cloud ones, but the application ones? Because for any of you who've been through this, they all built in the last couple generations back their own security, proprietary rubbish basically, but but they didn't have anything else, so they had to build something. The clients demanded it. And I think there's a real risk here that they just start building their own infrastructure around security, and then just you get that coexistence nightmare, and then away we go back into the old friction world. So I don't know, are you guys inviting those top 10, 20, 30 providers to your world? Because if you don't, they're going to build it and you're going to be in conflict anyways, like we went through with the Linux wars.
Yeah. I mean, I can say this is me personally. There's organizations that often invite in, and sometimes I attend these events where people are larger companies are joining in. But I'm a small little guy. I'm a startup, so we don't have that pool to pull in the big guys. But that being said, I would say that is generally the trend right now is for folks to build their own systems out internally and figure that out right now because there is no de facto methodology for doing this, and so whether these larger organizations align, certainly in conversations, but I can't, it's going to depend on them and partly industry and for folks to push it in the right direction. So yeah, it's a larger industry question. It's a good question though. I think I saw one other question as well. I think that was it wasn't from Lynn. Who had their hand up? Was it Jim?
Yeah, I had my hand up. I was just going to kind of comment on Aaron's commentary, and to his point, I would add, coming from the standpoint of participating in some federal identity management and identity security working groups, much like what he described in Fortune 1000 environments. Of course, the U.S. federal government has always been very heavily invested in federated architectures, PIV and CACs, and all of the various vendors that he's referring to. But I've been excited in the course of just the last couple of weeks and months. There has been more consideration about the dynamic requirements for identity and access management considerations for agentic AI that the traditional sort of, hey, we invested in all this PIV and CAC and X509 certificate architectures aren't going to scale, and revisiting the old conversations about attribute-based access control versus roles-based access control. So just kind of moving that philosophical discussion to think about re-engineering these models, I think is going to be important. Now, of course, Okta, Imprivata, and the like, they deliver what customers are asking for, but they are flexible enough to respond in these changes as we come up with new standards and new frameworks and new ways to do things that are recognized and demonstrated. So,
Love it. Really good point, Jim.
All right. If there are no more questions, then I think we can wrap this up. So I think a lot is possible now, a lot is happening, but there still remains a lot to be solved to be able to trust all that is emerging. Yeah. So thanks everyone for joining. The recording will be available on YouTube. We will email or send a message through Meetup to all the participants. And if there are any resources later on, Andor, that you want to share, then you can also pass them on to us.
Perfect. And thank you for
And
inviting me, by the way. It was a pleasure, and thanks for the reach out.
thanks so much for being here. I think you are the best speaker imaginable for me to talk about all of this. Yeah. Thank you. Have a
Thank you,
nice
guys.
evening or a
Yeah,
nice
thank you
day.
for organizing, Shane.
My pleasure.
Thank
Well
you.
done. Thank you.
Bye, everyone.
Bye-bye.